Welcome. My name is Martin Litwack, a lecturer in the Mathematics and Computer Science Department at Kingsborough Community College. This video, the second in the preparation for the CUNY Elementary Algebra final exam, provides worked-out solutions for Sample B. Sample B is similar to Sample A. If you want more detail for a particular question, please refer to the same question number in Sample A. Both samples are found at the link in front of you. Your feedback is encouraged. You can email me at mlitwack@kingsborough.edu with comments and/or suggestions. Now please keep in mind that most problems in math can be solved in more than one way. The methods I've chosen here may therefore differ somewhat from those used by your instructor. This is normal and to be expected. If you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you are having difficulty with a particular problem type, this video will hopefully help you understand it better. I have solved most of the problems in one way in order to avoid confusion. Occasionally, though, I have provided more than one solution in order to more fully explain an underlying concept. Well, good luck and let's begin. Again, I encourage you to download this sample exam if you haven't already from the following link. Problem number 10 asks you to find the factor of the given polynomial. When you see four terms, grouping is the method of factoring that you want to use. There's no guarantee that in general grouping will work when there are four terms, but the problems they give you, you'll know that grouping will work. What you want to do initially is to group the first two terms. Just isolate them. It doesn't make any algebraic change. So we'll put a set of parentheses around the first two terms. Next, what you want to do is find the GCF for the first two terms. What's the largest number that goes evenly into 45 and 63? That turns out to be 9. And then you look at the letters. You see C is common to both terms. Its lowest exponent is 1, so we write C. Neither W nor Z is common, so our GCF is 9C. Now we'll open up a pair of parentheses and we distribute. We want to get 45CW. So that would be 5W. And now 9C times what gives me 63CZ. That will be 7Z. And now we repeat the binomial and determine what has to go right in this area here, so I'll get negative 20 dW. So we'll put minus 4, that will be negative 20W, we need negative 20 dW, so we'll add a D. And now let's check that the other term, when distributed over, will give us the negative 28 dZ. And we see we do get that, negative 28 dZ. So now what we do is factor out the common binomial, 5W plus 7Z, and we're left with 9C minus 4D. Now they ask which is a factor, so 5W plus 7Z appears as choice C, so that is the answer. If you want additional detail with question number 10, refer to question number 10 on sample A. Problem number 11 wants you to translate the English 30 subtracted from 7 times a number is 4 into mathematical symbols. Now in sample A, we saw they gave us less than. Here they're giving us subtracted from. When you're doing a subtraction problem, when you're translating from words, you need to make sure you subtract in the proper order. And the way to do that is to determine what number you would put in the calculator first. So for example, if I said 1 subtracted from 3, what would you place in the calculator first? You know the answer is 2. You're taking 1 from 3, so the calculator would want you to say 3 minus 1. So you see the second number is going to go first. So here, the first number that they tell us is 30. And then 30 is being subtracted from 7? No. 30 is being subtracted from 7 times a number. And when you do that, the result is 4. Now, looking at the choices, you see the letter is going to be y here, and they also tell you y in the question to use y as the variable, a number. So we're going to say 7 times a number, 7y, minus 30 is equals 4. So that corresponds to choice C. Problem number 12 asks us to solve for x. Now, when we're done, we'll have x equal some number. The problem as it stands now is that this x here is stuck inside parentheses, so we'll need to distribute as our first step. So we'll get 18 minus 5x, distributing negative 3x. Negative 3 times negative 2 is positive 6. Now we need to get the x's on one side and numbers on the other. Doesn't matter which side. I'm going to place the x's on the right side since that will make the x's positive, but you don't have to do it that way. You could put them on the left if you like. So I'll add 5x to both sides, and this gives us 18 equals negative 3x plus 5x. The positives went out by 2 plus 6. We want to isolate the x, so we'll subtract 6 from both sides. That will give us 12 on the left side and 2x on the right side. We don't want 2x, we want just x. So we'll divide both sides by 2. So we'll get 6 on the left, the 2's cross out, equals x. So 6 equal to x, or x equal to 6, corresponds to choice B. Problem number 13 asks you to solve the given system of equations for x. I encourage you to look at problem number 13 on sample A. I solve it in much more detail. There are two methods of solving a system. One of them is called substitution, and the other is called elimination. We will solve this system by substitution because when one of the variables has a coefficient of positive 1 or negative 1, that makes substitution easier in most cases. So I'm going to label each equation so I know which one I'm dealing with. This is equation number 1. This is equation number 2. And now I will begin the process of solving for x. X is the variable for which they asked me to solve. I'm going to repeat equation number 1 here because I'm now going to perform some algebraic manipulations. So I will write it here, 2x plus y equals 3, and I'm going to solve for y. It's very easy to solve for y here because it's 1y. So I will subtract 2x from both sides, and I'll be left with y equals 3 minus 2x. At this point, I want to solve for x. Well, what I wind up doing is plugging in y, whose value is 3 minus 2x, into the other equation, into equation number 2. So I'll place equation number 2 here, and it starts out with negative 5x minus 2 times y. Well, I just found y, so this is what I'm going to plug in here. 3 minus 2x equals 4. So continuing, I'll now distribute. I'll get negative 5x minus 6 plus 4x equals 4. Let's combine like terms on each side. I have negative 5x plus 4x, so that's negative 1x or negative x, minus 6 equals 4. I'll add 6 to both sides. I'll finish the problem over here. So that will give me negative x. When you don't see a coefficient, it's assumed to be 1, equals 4 plus 6 is 10. We'll divide both sides by negative 1, since we don't want negative 1x, we want 1x or x. And the result will be x equals negative 10, which is choice B. Problem number 14 is an example of a literal equation, an equation with more than one variable name. They ask you to solve for x. All the other variable names will just pretend or view them as constants, as numbers. You'll see what I mean. So, as usual, when you want to solve for a variable, you isolate it. So, we'll begin by adding 7y to both sides. And on the left, we will get z plus 7y. And on the right, we'll get 5x. So all we have to do now is to solve for x. So we'll divide by 5, both sides, and we're done. X equals z plus 7y over 5. So the answer is choice A. Problem number 15 asks you to find all solutions to the equation. when you have an equation in one variable and the highest exponent of that variable is 2, that's how we identify a quadratic equation. And they usually have 2 unique solutions, so we're not surprised when the problem asks us to find all solutions. Now, as we saw in problem number 15 on the sample A video, the first thing you want to do is set the right side to 0 when you have an x squared, when you have a squared term, and you have just the linear term, the x. So when you have an x squared term and an x term, you want to set the right side to 0. So we'll do that by subtracting 15 from both sides. So we get x squared plus 2x minus 15 equals 0. Now, even though it's not explicitly stated, when you have x squared with no coefficient in front of it, it's really a 1. So this is really a 1x squared, which tells us that we're dealing here with a quadratic equation, the simple case. So the simple case is when a equals 1. Remember, the form of a quadratic equation is ax squared plus bx plus c equals 0. So we need to find factors of negative 15 whose sum, that adds up to, whose sum is positive 2. So the factors of negative 15 are either 5 times negative 3 or negative 5 times positive 3. We want the pair whose sum is positive 2. So the first pair, 5 plus negative 3, gives us 2. So that will be the one we use. So now we'll factor. We begin with x and x. And now we know that we need to insert positive 5 and negative 3. Let's check. X times x is x squared. Positive 5 times negative 3 is negative 15. Now we need to come up with positive 2x. So 5 times x is positive 5x. And x times negative 3 is negative 3x. 5x take away 3x is 2x, so that's what we want. So now we have two factors being multiplied together to give you 0. The only way two factors can be multiplied together to give you 0 is if one or both is 0. So either the first factor is 0 or the second factor is 0. Let's solve each of these mini equations. We'll subtract 5 from both sides. And our first solution is x equals negative 5. And our second solution will be found by adding 3 to both sides. And we'll get x equals 3. So our two solutions are x equals negative 5 or x equals 3. And that corresponds to choice A.